we're going to take a look at solving one-step inequalities, and it's really similar to solving equations. The only difference is obviously the inequality sign instead of the equal sign, and really when we do this we follow the same exact procedures, the same steps, and we just leave the inequality sign the way it is, just like we would leave the equal sign there. There is one exception that we will get into later on, not quite this lesson just yet. But the idea when we solve an equation and or an inequality is to get this variable by itself. So we have to get v by itself. And in order to do that, we undo whatever is being done to that variable. So I'm going to rewrite the inequality over here. So to get rid of plus 10, we think, what is the inverse operation of adding 10? And that is subtracting 10. So we're going to subtract 10 to get rid of it, but it's still like an equation where whatever we did to one side of the inequality, and the sides can be separated by the inequality. So we subtracted 10 from the right-hand side, so we also need to subtract 10 from the left-hand side, and that will leave us with 7. As we said, the 10 is gone now, and then we just keep this inequality the same. So we have 7 is less than or equal to v. Now, inequality signs, most people are taught that the inequality sign is kind of like an alligator and it wants to eat the larger number. So in this case, v is larger. So it is also okay. A lot of people like the variable on the left-hand side. So if we wanted to switch this around, we could do that. But just remember, since the v is larger than the 7, we would still have to have the alligator eating the v. All right, both of these answers would be acceptable. I'm going to go ahead and put v is greater than or equal to 7 in for the answer here. So v is greater than or equal to 7. And let's move on to the next question. Same idea. We're trying to get the variable by itself. So to do that, now we're looking at how do we get rid of minus 5? How do we undo minus 5? And to undo minus 5, we add 5. And once again, to both sides of that inequality. 22 plus 5 is 27. This equality stays exactly the same. So it's greater than or equal to, and now we just have v by itself. All right. In the last problem, we switched it around. So we put the variable first, and now 27 is larger, so the alligator is kind of eating the 27. I'll put little teeth on here. See if we can make him an alligator. This is a pretty bad alligator here. Get the idea. So anyway, the alligator is eating the 27, so when we switch it around, we still have to have the alligator eating the 27. All right, but to show you that both answers are going to be acceptable, this time I'm going to put 27 is greater than or equal to v for the answer. So I'm going to go ahead, 27 is greater than or equal to v. All right, moving on to the next one. So now we have 13 plus u is less than negative 11 here. I'm going to bring my marker back up. Now this one's slightly different because we have to undo this plus 13. And what's important to remember is that you have to look to the left to see what the sign of the number is. This plus sign actually goes with the u. All right, it doesn't go with the 13. What we have to look at is right here. What's in front of the 13? And since there is nothing there, we assume that it's positive. So in order to undo that positive 13, we would have to subtract 13 from both sides, and that leaves us with a positive u. We keep this inequality sign the same, so this one is just less than this time. And negative 11 minus 13, they're both negative. So we kind of add these together. 11 and 13 is 24, but we just went in the same direction on the number line. So u is less than negative 24. And I wouldn't even mess around with changing the order of this because we usually like the variable on the left-hand side. So we're just going to say u is less than negative 24. So u less than negative 24. So it's all about trying to figure out what do we need to do to the variable to kind of undo things. All right, so now we're getting into some fractions, but the idea is exactly the same. So I have v plus 3/8, and before I write this down, I automatically know to get rid of this 3/8 to undo addition, I would subtract 3/8. All right, and then this doesn't work unless I subtract 3/8 from both sides. So I would subtract 3/8 from the other side as well. And if you have a calculator capable of fractions, you can put in negative 1/4 minus 3/8. If not, we're going to have to change some denominators here. So this negative 1/4, I would change to negative 2/8. So I have common denominators. And I would end up with negative 5/8 here. So our answer, v is greater than or equal to negative 5/8. So we've got v, going to use the greater than or equal to negative 5/8 here. So we put in the fraction. Let's go ahead and move on. So we've got 15 plus v. This is very similar to one that we did earlier. I think it was 13 plus v, just happens to be on a different side now. So 6 is greater than 15 plus v. To undo this 15, once again, it's a positive 15. So I would put minus 15. All right. And the reason that undoing works, if you think about this, 15 minus 15 is 0. And then 0 plus v, that just gives us v. So that's how the using inverse operations works. We just kind of usually skip that step of adding 0 because everybody knows that 0 plus something is whatever we end up with. So we have the v on that side. And 6 minus 15, 15 is bigger than 6, so it's going to end up going into the negatives. And we end up with negative 9 here. And once again, some people prefer the variable on the left-hand side. So if I wanted to do that, I would have v is less than negative 9. Once again, the alligator is eating the 9 in both of these situations. So v is less than negative 9. All right, another fraction problem where we would get the x by itself by subtracting 5/6. And we don't have a common denominator. So as I write this problem down, I'm actually going to write it with new denominators. So 5/6, common denominator of 6 and 5 is 30. So I'm going to multiply both of these by 5. So I'm going to have 25 over 30. And to change 1/5, so it has a denominator of 30, we have to take the 5 times 6. So I'd have 6/30. So when I have to get rid of the 25/30, I think, what is the inverse operation of addition? And that is subtraction. So I'm going to subtract 25/30 from both sides. Keep the inequality sign exactly the same as what it started. And when adding and subtracting fractions, we leave the denominator the same. 6 minus 25 is negative 19. So we have x is less than or equal to negative 19/30. X is less than or equal to negative 19/30. All right. Now the last few problems here are dealing with multiplication. All right, so we're using addition and subtraction. They are inverses of each other. To undo multiplication, the inverse is division. So in this situation, to get rid of times 6, to undo multiplication, we would divide by 6. So 54 is less than or equal to 6v. So since it's 6 times v, we would divide by 6, once again, in an effort to get that v by itself. So 54 divided by 6 is 9. Same thing, we're leaving the inequality alone. That's staying the same, and we get v. This is where the exception comes into play. If you ever divided or multiplied both sides by a negative number, that's when that inequality would switch. Now, we don't see that here yet, but just to kind of give you a precursor of what's to come. But otherwise, the inequality stays exactly the same. So this time we have 9 is less than or equal to v. So I'm going to go ahead and put that in. 9 less than or equal to v. Our next question is 5w is greater than 40. So 5w means 5 times w. So just like we just had, to undo this multiplication, we would use division. So we would divide both sides by 5, keep the inequality the same. 40 divided by 5 is 8. So our answer is w is greater than 8. W greater than 8. Next question. We're dealing with a negative sign, and this is what we were talking about. This is the only time where we're going to change that inequality. So when we have negative 4 times u, we would divide by negative 4 on both sides. And this is when you divide both sides by a negative, that's when you have to switch that inequality. So right now, it has less than or equal to, so we're going to switch that around. I'm going to do my best to kind of draw a little twisty. So spin that around so it's greater than or equal to, and 20 divided by negative 4 is negative 5. So that's the only difference really when you're solving inequalities, the difference between that and solving an equation. Equations, equal sign always stays equals, but inequalities, it will switch if you divide both sides by a negative. So this particular problem, we have u is greater than or equal to negative 5. Let me go ahead and put that in. U is greater than or equal to negative 5. And one more question here. 10 is greater than or equal to negative 5x. So this is another example where we're going to be dividing by a negative. So when we divide by this negative 5 on both sides, that's our cue right there to flip the inequality. So instead of greater than or equal to, it's going to be less than or equal to. And we have negative 2 is less than or equal to x. And once again, if we want to switch this around and get the variable on the other side, remember the alligator right now is eating the x. So if I want the x on the left-hand side, the alligator still has to eat it, and we keep negative 2. So x is greater than or equal to negative 2. There we go. I hope that helps. Don't forget, I'm just going to go to try another. When you're looking in Alex, we've got options here. This example will give you a problem very similar to the one that you're working on, and it'll kind of tell you how you would solve this problem, just like we were talking about. So it's showing you right down here, this is the original problem. Let me get a marker right here. This is the original, and this is how you would do it. You would To get rid of the times -3, you would divide by -3 on both sides. And because we're dividing by -3, it says right here, flip the inequality sign. And these are always available on Alex to try to help you out with an explanation. So I hope this helps, and good luck.